Pre-calculus. Today we're going to look at section 4.6 in our textbook on rational equations. This will be the last algebra-related section that we cover in that part of our class. After this, we will switch to trigonometry. Today, rational equation. Recall from Algebra 1, the word rational has ratio in it. Ratio is a comparison of two numbers by division. So anytime you see that word, you need to be thinking fraction. A rational equation is an equation with one or more fraction expressions. Your goal is to solve the equation, obviously, for the variable. In order to do that, you need to multiply each side of the equation by the LCD, which is the least common denominator. When you're solving or after solving, looking at the solution, you want to make sure you do a quick check. You want to exclude any solution that causes the denominator in the original problem to be 0. If that happens, then you would have to get rid of that solution because obviously it would cause the problem to be undefined. So after solving, make sure you do a quick check to see if your answers will be true for the irrational equation. Example 1. Solve 6 divided by x plus x is equal to 5. Notice that the first part of this problem, this equation, is a rational expression. Also, you can think of x as a fraction if you want. You can place it over 1, kind of just visualize that. And your goal is to solve for the variable. In order to do that, since I do see a rational equation, I'm supposed to multiply the entire equation, both sides, by my LCD. My least common denominator is me looking at x and 1. Often you can just multiply those together and it works. So my LCD for this problem would be x. And so you would show like brackets or parentheses around the whole problem, and you would put x up here. You're going to make sure that you multiply both sides, everything, by x. So if I multiply all the way through, like this would be, visually speaking, x times 6 is 6x divided by x. Then x times a positive x would give me x to the second. And again, you can place it over 1 if you want to. I'm going to choose not to right now. And then multiplying x times the 5 would give me 5x. And so whatever you decide the LCD is, and that will be the challenge part of the section, is trying to figure out what should you do, what should you multiply by. When you do choose this LCD, which is here, make sure you multiply it by all terms that you see. The first term, of course, when I have a 6x divided by x, the x's are going to cancel. And so I'm basically going to be left with a 6 plus x to the second is equal to 5x. We all can see right now it's a quadratic equation. It's just not in the right form, standard form. So I'm going to drop my x to the second down. Choose to transpose my 5x across the equal sign so it becomes minus 5x. Drop my plus 6 down, and then set it equal to 0. Anytime we're dealing with polynomial equations, we know from the past to make sure it's set equal to 0 before you can solve. Next, if it's quadratic, I know to try factoring, quadratic formula, synthetic division if I choose, but I'm going to try factoring first. We're looking for factors of 6 that will give us a sum of 5. So we're going to factor out x squared into x times x. Factors of 6 are 1 times 6 and 2 times 3. Notice the last sign's a positive, so the signs in the answer must be the same. Remember that you're always paying attention to the middle sign, and that's going to help you know what to write. So 2 negative signs. Again, 1 and 6, 2 and 3 are my 2 options, but the pair of factors that will add up to 5 for the middle term would be 2 and 3. Okay, next you're going to take each factor and you're going to set it equal to 0. and that's going to give me an x equals 2 possible solution. And then my second factor is x minus 3. I'm going to set that equal to 0 and solve and get x equals positive 3. Okay, so I'm going to go ahead and circle those right now, and then we are going to do a check to see if the solutions that I just got from that quadratic will actually work in the rational problem. And on the check, you really can often, if it's an easy question like this first example, you should be able to just look at it and tell without having to write it down. It really just depends on the difficulty of the problem. For example, if it's x is 2, when I put 2 up in the original problem, I'm going to be looking at it like this: 6 divided by 2, and then plus 2 equals 5. And I know that just based on what I'm seeing right now, that this is going to be 3, and 3 plus 2 is 5, and it's definitely going to work. 3 is the second option. Me just writing it out so we can see. That's going to be 6 divided by 3 plus 3 is equal to 5. And that is going to allow me to see 2 plus 3 equals 5, and of course that works as well. So both of these answers, x equals 2 and x equals 3, are valid solutions to this original rational equation. Remember, when you're checking, if it causes the problem to be undefined, in other words, if I had gotten x equals 0 as one of these options, I obviously would have to throw that out. Okay, example 2. 7 divided by y minus 1 minus 4 divided by y is equal to y divided by y minus 1. I can tell it's a rational equation. Obviously, I see equal sign, I see fraction bars. I have two denominators that are the same expression and one that's different. To figure out what I'm going to multiply by, which is my LCD, I would want to look at all these pieces, and basically I know this is in common with this, so I would not want to multiply by like a y minus 1 quantity squared, for example. I would just pick one of those binomials and that piece. So my LCD would be y times y minus 1. Please notice how I'm writing that down, kind of squeezing that in there, but I am supposed to multiply it by all terms. Okay, now with this part, I can look at it this way. When I'm multiplying y times y minus 1 times 7, of course that written out would be 7y, 7 times y, times y minus 1, divided by the original denominator. And so looking ahead, we should be able to see that that y minus 1 binomial is definitely going to cancel from top to bottom. So my LCD times this first fraction is none other than 7y. I'm going to go ahead and skip to the next step. I take my LCD of y times y minus 1 and multiply it by this negative 4 divided by y. Me writing it out so you can make sure you're staying with me is negative 4y times the quantity y minus 1. And then you're going to still divide that by the original denominator of that fraction, which is y. We can look at this expression. Notice that these are factors. They're being multiplied. So we are allowed, if we see the same thing on top and bottom, to cancel that. Y divided by itself is 1. So basically that means that I'm going to be left with a minus 4 parentheses y minus 1. Okay. Next, you're going to take your original LCD, multiply it by this third fraction. Y times y would give me y to the second, parentheses, y minus 1. And then I would drop down my original denominator. Remember, when we're multiplying fractions, we're just multiplying top times top and bottom times bottom. And so by that, you could say like 1 times this is this expression. Okay, notice that I'm seeing that binomial show up again. Y minus 1 on top and bottom is 1, or it cancels. So I'm basically left with just y to the second. Okay, now we've got some simplifying work to do on the left side, of course. We want to drop down 7y. We want to distribute that negative 4, get rid of those parentheses. So that's going to be a negative 4y, and negative 4 times negative 1, positive 4, and that's equal to y to the second. Okay, simplifying a little bit further, we can see 7y minus 4y is 3y plus 4 is equal to y to the second. And similar to the last example, I can tell obviously this is a quadratic equation. I see power of 2. It's not in standard form. So I'm going to choose to write y to the second. Notice I'm not moving it to the left side because then it would create a negative. I'm going to bring my 3y this direction, making it minus 3y. And the positive 4 is going to transpose to be a minus 4. We put the 0 in front. We see a quadratic. It is a trinomial, so we're going to see if it factors using that method. Factors of y to the second are y times y. Factors of 4 are 1 times 4. I see a minus sign, so the signs are different. I definitely want negative 3y back when I check it. So I want the bigger number to be negative, smaller number to be positive. And you're just checking the outside, negative 4y, inside positive 3 or positive 1y, and so that means it does check out. I do have the right factors. You're going to take each factor and set it equal to 0. This one appears to be easy. They're both linear. And so one possible solution is y equals negative 1. When I take the y minus 4 and force it to equal 0, then another possible solution is that y is positive 4. Okay, and then you're going to go back up. I've got 4 and negative 1, and I'm going to look at my original problem. 4 was one of the answers. If I place 4 in for y, this fraction would be like 7 divided by 30, and that's definitely an acceptable fraction. It's not undefined, so that's good. If I put 4 here, I can definitely simplify that, and it's going to work here as well. So 4 is a good answer. The second option we got was negative 1. Me putting negative 1, substituting it in place of y, is going to not cause any of these fractions to be undefined. So because of that, negative 1 is also a good choice. So there are 2 solutions to example 2. Okay, example 3. A divided by 1 plus a squared minus 5 divided by a squared minus 1 is equal to this trinomial divided by a plus 1. Please note that in the second fraction, the second rational expression, remember you cannot cancel a squared with a squared here because it's part of this binomial term. It is not being multiplied by 5. It is actually, 5 is being subtracted from it. So keep that in mind. Please don't make that a math error and cancel pieces that look the same unless they are factors. We're trying to solve for a. We're looking at the denominators. Each of these are different. One thing I notice, and you need to make sure you're paying attention to this on your set of problems too, is that if you notice that part of a denominator or one denominator is a factorable problem, you want to do that. And so you want to simplify the best you can. So that's the first thing I'm noticing. I see a squared minus 1. That is a difference of squares, so we're going to go ahead and factor that right now. And that should allow you to find the LCD a little bit easier. Also, notice that the numerator of this last fraction, it looks like a trinomial, so we can see if that factors. Go ahead and try that as well. So anything you notice, hey, I think it factors, make sure you try. Factors of a to the second are a times a. Factors of 2 are 1 and 2. Like signs. And so if I do 2 plus signs Oh, but notice the middle. I'm trying to get back a positive 1a, and I'm going to end up getting back 3a back. So this time, this problem, that trinomial, does not factor. Yeah, you could try quadratic formula, but that's showing me because it doesn't factor, it's probably going to be a messy decimal. So in that case, when you can't get it to factor, and you've tried all options of factoring, that's just telling you, okay, let's just keep it the way it is and write it back down. All right, and then back over here, hopefully you notice this. I didn't factor this because 5 is not a perfect square. It's not an example of a DOS. Okay, next, big bracket around the whole problem. And we're looking for an LCD. And right now, I am noticing that I have 2 of the same binomials. So when I'm trying to decide what to write over here for my LCD, I would definitely only want to use one of those. Using 2 would actually, I mean, it would still work, but it would create a lot more extra work on you. So anything times you see something that's in common, just use it one time in the LCD. And then you would also want to grab the a minus 1. So your LCD is a plus 1 times a minus 1. All right, next, you're multiplying this binomial times a, so you're going to end up getting a times the quantity a plus 1 times the quantity a minus 1, and then over 1, but I'm going to choose to skip that. And then I'm visualizing this binomial times this binomial times this binomial divided by these two. And I'm going to speed it up this time. The same a plus 1 is on the top and bottom, so that means it's going to cancel. A minus 1 is on top, divided by 1 on the bottom. That means it's divided by itself, so it's going to cancel. And so that's going to only leave me with an a squared minus 5 right here. Okay, then I take the LCD and I multiply it by the last fraction, but think ahead, notice that there's an a plus 1 on top and an a plus 1 on the bottom, so technically you can say these are gone, leaving me with an a minus 1. Make sure you use parentheses around it, times a trinomial that we could not get to factor earlier, so a squared plus a plus 2. And so the rest of this is you just simplifying and trying to solve for the letter A. All right, so a lot of calculation here, a lot of algebra work. So we're going to multiply in any order. I'm going to choose to drop my A down and just kind of multiply these together as quickly as I can. FOIL allows me to get a the second. Notice that since they're conjugates of each other, opposite signs, the outside and inside are going to cancel, so I'm going to skip that step. And then the L in FOIL is going to give me a minus 1. Okay, on the right side, I'm going to notice there's a binomial times trinomial, so I'm going to have to end up distributing here a times all terms in the second parentheses. That would allow me to get an a to the third. A times a is a to the second. And a times 2 is 2a. Okay, then I'm going to come back and grab the negative 1 and distribute it towards the second parentheses. End up getting a negative a to the second, a negative a, and a negative 2. All right, back to the left side. We need to distribute the a. We're going to have an a to the third term, a minus an a, plus a to the second, minus 5. And then on the right side, I'm going to go ahead and cancel a squared with a minus a squared. I'm going to drop my a to the third down. 2a minus a is going to give me like 1a. So anytime you can simplify terms left to right, definitely do that. And then a minus 2. So all of this simplifies to a to the third plus a minus 2. We can tell that it's a cubic equation right now. So next, our goal is to get it in standard form. So let's put all terms on the left and set it equal to 0. So you should see a to the third. This a to the third is going to come over as a minus a to the third. We're going to drop down our, let's put it in descending order. So a to the second next. I'll see an a squared over here. We're going to drop down this minus a on the left and bring over the positive a with it. We're going to drop the minus 5 on the left side and transpose the negative 2 across and make it positive 2. And I believe I've transposed everything I need to, set it equal to 0, and then simplify best you can. Obviously, these two are going to cancel, which is good. I notice an a squared term, so for the third time today, we're seeing a quadratic equation. And then I'm noticing that these are like terms. They're not conjugates, though. They're not opposites. So we're going to end up getting like negative 2a. And then constants combined together, negative 5 plus 2 is a negative 3. And then you're on your way to solving. It's trinomial again, so we're going to see through factors. We're going to do an a times a. Try that again. Okay, and then factors of 3 are 1 times 3. Notice last sign's minus. Awesome. Signs have to be different. And I want it to add up to a negative 2. So we'll put the negative on the 3. And then you can do a quick check outside, inside. Make sure it's working for you. And then you know the drill. We know to take each factor that I've underlined and set it equal to 0 and solve. And then as soon as we get to this point, this is easy to solve. Transpose, we're looking at a is negative 1 possibly, and a is possibly a positive 3. So negative 1, positive 3. Then we go back to the original problem. Let's see, negative 1 and positive 3 were the two values I just got. Let's do a quick check. If I put negative 1 in for a, focus just on the denominator, please, because that's what we got to look at. We don't want this to be 0. If I put negative 1 here, negative 1 squared is 1. 1 minus 1 is going to be 0, and that is a problem. We can't divide a squared minus 5 by 0. Notice it's also going to cause a problem with this fraction. So even though we did show all work and negative 1 is a solution to this equation right here, it's not a solution to the rational one. So you would actually throw that out. And then you would try 3. 3 on the bottom, 3 squared is 9. 9 minus 8, yes, or 9 minus 1 is 8. We can divide something by 8. And then 3 plus 1 is 4. We definitely can divide by 4. And so 3 is a good solution to this rational equation. There are several other examples that we'll do when we get tomorrow, when we get back in person. But for now, we'll pause in our notes today. And just make sure that you have written everything down, that you understand everything I've said, and that will allow you to move forward and try some of the practice problems. Bye, guys. Have a good day.